Aloha class, today we are in section 6-7. Now when we're dealing with section 6-7, we are dealing what we call inverse relations and functions. Okay, and our objective is to find an inverse of a relation or of a function. So what we have here in our first example is we have a relation S, and then we're going to talk about the inverse of relation S. And if you look at these two right here, the only difference is that if this is the relation of S, for these two guys right here to be inverses, it says it right there, you switch the X and the Y values. So if 0, -1 is on S, on the inverse of S would be just flip-flopping it. So if you notice for each one of these guys, they're just flip-flop. And if that's the case for each value, each coordinate, if they are flip-flop for every single relation, then that means they're inverses of each other, okay? And that's it. That is all it would mean for these guys to be inverses of one another, okay? All right, let's keep rolling here. What is the, okay, so now we're going to introduce, okay? And remember, when we say something like y equals x squared minus 1, a lot of the times, like on the SAT, they'll say find the inverse of this particular function. And we go through some steps and able to find the inverse. Okay, normally, and make sure you take good notes on this, our first step would be to let y equal f of x. So our first step, and I'll kind of write these in steps here, we're going to write y equals x squared minus 1. And make sure you take good notes, okay? Now, to find the actual inverse of this relation, of this function, we would first, after rewriting it as y equal, we would switch the x's and the y's. And then, believe it or not, the inverse is if we were to get y by itself. So let's all now get y by itself. How would I do that? Well, we would add 1 to both sides, and then we would get x plus 1 equals y squared. And then remember, how do I get rid of that little 2 up there? Well, the way I get rid of that little 2 up there is I square root both sides, okay? So we're going to square root both sides. And remember, that is a even root. So I've got to remember that plus or minus. And then, believe it or not, that would be the inverse. And then we have what we call function notation for an inverse. And the function notation for the inverse is this. If this is the original, its inverse would be this. Okay, we draw this. It's like a -1 exponent up there. And this is how we always want to write our final answers if they give me the problem in function notation, okay? And here they didn't give it in function notation, so we would just find its inverse, and its inverse would be just switching those x's and y's and solving for y, okay? And that's all you have to do for that particular one, okay? All right, let's go to the next guy. All right, what? Ooh, it's not erasing here for me. Let's get this guy erased. Boom, boom. Okay. All right, so what is the inverse of y equals 2x plus 8? Okay, let's go. What's step 1? Well, step 1 is to write y equals, right? And it already is because it's not in function notation. So my next step, step 2, is to switch the x and switch the y. Isn't that kind of cool? And it's going to actually give me the inverse. So it would be -8 minus h, blink. And then I get x minus 8 equals 2y. How do I get y by itself? Divide by 2. And then you could write that as x over 2 minus 8 over 2, which is 4, equals y. And that would be the inverse. And there's no rule that says you got to put y on the left-hand side or y on the right-hand side. The only thing you would have to do is if it started the problem and it gave it to you in function notation, your final answer, your step 3, and I didn't write step 3 in the previous step, I apologize, would be to rewrite it like this. Okay? But remember, you only have to write it in function notation if it's given to you in function notation. Okay, class? Hopefully not too bad. All right, let's keep on going here. There we go. Erase work that time. All right, so now we're going to take it and we're going to go a little bit more crazy with this because we're going to bring in the idea of domain and range. Well, what the heck is domain? Domain stands for what could you put in for x and get an answer. That's all domain talks about. So let's go ahead and look at our domain. What the heck could I put in for x and get an answer? Well, usually when we're finding domain is we want to start off by saying everything in the world works, but what might not work? Okay, and I see a radical, and a radical should be red flag, red flag. And what is a red flag in a radical? Well, the red flag in a radical, especially right, if it's an even root, is that it can't be negative. So we're going to set up a little thing to help us define the domain. We're going to say that what's underneath that radical has to be what? Greater than. Could it be equal to 0? Square root of 0? Square root of 0 is 0. So we set up that. So whenever we're dealing with a radical that has an even root, we always want to set up what's underneath the radical and set it greater than or equal to 0. I'm going to add 2 on both sides. And so I get this as my domain. Okay, x is greater than or equal to 2. Now that is what we call inequality notation because it has an inequality in it. Okay, interval notation would be, do you know what interval notation would be? It would be this. X can be 2, but it's got to be bigger than 2. So x could be from 2 to infinity. And those are the 2 ways you want to be able to do it because you never know what comes up on an SAT. All right, what's the range? Well, let's think about this. This is my problem here. Okay, all there is a radical. So the answer has got to be bigger than 0, right? It's got to be bigger than 0. Could it be negative? No, because you can't take the square root of a negative. So my range, best way to think about these, domain is what can x be? Range is what could y be? Now remember, this is really y equals. So what could y equal? Well, y could equal anything that's bigger than or equal to 0, right? Because the square root of 0 is 0. And remember, the other way I could write that is 0 to infinity. Okay? All right, here we go. Now, we are given it in function notation. So this is where we're going to use the true 3 steps. So the first step would be to write it as y equals. Do you remember what the second step is? Yep, flip-flop. You switch the x and y, and then you solve for y. So I got to get y out of there. Well, how do I get y out of there? Well, I have to get rid of the square root. How do I get rid of a square root? Well, there's a little 2 there, so I'm going to square both sides. So that's going to give me x squared equals, remember when I square that side, it's really 2 over 2 because you have a root of 2 and then you square it, right? So it gets rid of it. And then all I have to do now is add 2 to both sides and I get x squared plus 2 equals y. And then my step 3 is they gave it to me in function notation. So I write it so pretty. Okay, equals x squared plus 2. Spling. And then look at this. This asks for the domain and range of y. And guess what? We are going to cheat it because from the very first page, remember the x's and the y's flip-flops. So now my domain is going to be from 0 to infinity. Okay, and my range is going to be from 2 to infinity. Okay, and they just flip-flop. Remember, that's what we do when we talk about our inverses. Okay, guys? And the other thing you could maybe say is, well, you know, what could x be? And we kind of would say from negative infinity to infinity. Okay, but those aren't what our y's are. So we just flip-flop the domains and the ranges when we're talking about inverses. Okay, not too bad. All right, let's keep rolling. All right, what do we got here? Okay, got it. Do you understand it? That's what this little page is here. So all of you guys at home, I challenge you to take a quick pause, see if you can do this on your own, and then let's see if we all got the same answer. Okay, I'm really hoping you guys tried this on your own. Here we go. Stop it. Domain and range. All right, let's do domain. Okay, what is the domain of that? Well, guess what? We want to say everything works, right? What can I put in for x? I can put everything in for x, right? There's no square root. And what's the other red flag we want to think about when we're talking about domains? We want to look for those square roots, and we want to look to see if any variable is under. Like if we have a fraction. No fraction, no radical. So guess what? Everything is good to go. We go negative infinity to infinity. Inequality notation would look like this. Okay, x could be anything from negative infinity to positive infinity, and shame on me, you cannot equal an infinity symbol. So do not put the equal signs there. Okay, and then what is the range? Okay, let's see, what's the range? Well, range is what could y be? Well, same thing, no restriction. There's no division, there's no fraction, and there's no square root. So same exact thing, negative infinity to infinity. Or my inequality notation, whoops. It's got to be a y this time, right? Because range is y's, domains is x's. Okay, so here we go. B, how do we write the inverse? Okay, 3 steps on this one because they give it to me in function notation. It's even a g this time, right? But we still write y equals 6 minus 4x. Step 2 is you switch the x and you switch the y. Step well, kind of goes hand in hand. You get this guy by itself. Okay, then I got to divide by a -4. And remember, it's kind of helpful because the SAT would probably do this. A negative divided by a negative would be x over 4. And then what would -6 divided by -4 be? That'd be a positive 3/2. And that would be equal to y. Step 3 means I should rewrite this in function notation, right? Which would just be that. Just remember that it was g. And there you go. That is it. That is our inverse. Do they ask me for domain and range? Oh, they asked me that first. I apologize, you guys. Oh, no. Well, oh, yeah. And part C was to find the domain and range. Well, look at the domain and range of G. That means G inverse is going to be the same exact domain and range, right? Because they just flip-flop and everything worked the first time. Everything's going to work the second time. Gays? And it has this question of, is G inverse a function? We'll talk about that in class. All right, let's keep going here. We're almost done, believe it or not. Here is a key concept. If you remember this little composition, dude, okay, 2 things, and I'm going to rewrite it here because this is very important. The reason why inverses are so important is if you actually did this, okay, right, and I don't even actually have 2 functions here, but remember, that means this. Remember, f inverse of f of x. If you actually did that and they were inverses, you would get x as an answer. No way, Jose. Yes, you do. But believe it or not only does that answer have to give you x, this one also has to give you x. And it's kind of cool. And we'll do some of these in class. It's a good way of verifying whether or not 2 functions are inverses. Obviously, here they say they are because of the notation, but they both have to equal x for them to be inverses. Okay? I don't know about you, but pretty cool that that works out that way. And so all of the problems we've done so far when we're finding inverses, they actually would all work out that way. All right, here we go. This one's just find the inverse of a relation, just some extra problems for you guys to do. I'll just talk about it really briefly, okay? Remember, if I give you a relation, like a table of values here, all you have to do to find the inverse, I guess we can attack one real quickly. The inverse of this number 8 would be simply just flip-flopping the x's and the y's. That's it. And that would be, and you'll have questions that okay on quizzes and tests. And that's how you would do 8 through 10. Okay, but I think you guys would be okay with like that. Let's see if there's any other tougher problems. Here's ones that are find the inverse. Okay, I think you guys would be all okay with that. You know what? Let's do one more. I think I see one kind of tough one here, and that would be number 20. Okay, so let's go ahead and look at number 20. Number 20, I'll put it right here. Okay, this is 20. Step 1 is to rewrite it with y equals. This one's already because it's not in function notation. Okay, remember, step 2 is to flip-flop your x and your y. So this is a little bit tougher, I feel like. Okay, now remember, in step 2, I have to get y by itself. Well, how do I get y by itself? Because there's a square up there. So I've got to get rid of this 2 because the y is stuck on the inside. Well, how do I get rid of that 2? Well, first I have to get that expression by itself. Well, how do I get that expression by itself? Well, I subtract 5 on both sides, and I get x minus 5 equals the quantity 1 minus 2y squared. Now I got to get rid of this little 2 because it's by itself, and I get rid of it by doing a radical on both sides. And remember, since that's a 2, that has to be 2 because 2 divided by 2 as a rational exponent gives me ichi, gives me 1, which if it gives me 1, remember, it gets rid of all of those parentheses and radicals and all that good stuff. So now how do I finish this guy? Well, I just have to subtract a 1 on both sides. Right? And just be careful. That's an expression. So the x minus 5 squared stays together. Minus 1 equals negative 2y. Then I'm going to divide by a negative 2. So if you notice, this one was a good doozy. Right? So that'd be x minus 5 squared over negative 2 plus 1/2 equals y. And that would be the inverse. Okay, and that's it for today, you guys. As finding the inverse, we talked about some domain and range. Some domain and ranges can be tough as we go on. We use composition of 2 functions to verify whether or not 2 functions are indeed inverses, or the relationship between composition and functions. It's got to equal x on both ways, right? You flip-flop them and they both have to equal x for them to be inverses. That is it, believe it or not, for today's video. Nice and easy Japanesey. I will see you all in class. Aloha.